I will start with an overview over the new functions. And my idea is to demonstrate these new functions based on a single task, a typical task beta log Z administrator will encounter in daily work. So what will we see? First, it's about deployment of configuration elements. And the point in this is that a new tool called B92 BUTLT replaces the former one B92 ULoad. The second very important new feature from my point of view is issuing a system message as a new event action type. And this new action type bridges the gap between log Z and the system-wide automation. Next point is the just applied job correlator can now serve as a filter criterion and can be displayed in the tabular panels. Next point will be the JES event log. It's a new source of information, again by JES, basically comprised of SMF30 records, which are produced at the end of steps and jobs. And it contains a lot of statistical information for a given job. And in order to be able to display all these new information types, we created new line commands which will display all available information for a given job or a given step. Next, we improved the handling of lists that exceed the outlim threshold, which can be defined with the class definitions. So now it's possible to retrieve and archive very large lists in the main started task without the necessity to create a dedicated started task just to read in large lists. And we are now able to save all output parameters in a new table called OGR, the output generation record. And the last one will be an example for the usage of extended selection criteria for filtering with logical OR connections. So I now switch to my TSO session. And we will start with the deployment of configuration items. So what is a configuration element? Anything an administrator creates using the administration dialogues, and that will be stored in the BQL database of log Z, we call a configuration element. Examples are reader definitions, class definitions, job group layout definitions, and in our case, serving as the base for all our examples, a scan definition. A scan definition basically is an instruction for the reader to extract certain text from the log lines and to store this extracted text portions into the BQL database. We will see how it works. Let us focus on one single scan definition. You see it here. Its ID is 20300, and the title is Original Extended Selection. So let us consider the following scenario. The administrator once created the initial version of that configuration element, in that case, the scan definition. Then he deployed that scan definition to other subsystems by a process of downloading the definition, transferring it to other subsystems as far as the other subsystems are located on other plexes. And the third step would be to import the downloaded definition by means of an upload utility into the target subsystem. For the first run, this works fine. But suppose a business need arises to change the original definition. So the administrator would try the same process. Download the modified definition and then upload or re-import the modified definition into the target subsystem. Let's see what will happen. First, I show you the content of the downloaded scan definition. In this case, it's a member of a PO dataset. And for demonstration purposes, I already modified the scan title. You can compare this. In our system, the title is original for the scan definition 2300. And in the modified control cards contain modified extended selection for the same definition ID 2300. So first, we tried to use the well-known procedure. And let's have a look. You see, we get an error. We get a duplicate key condition. So we will see these messages. A duplicate key condition, key must be unique, an internal command error, and the information program return code for duplicate key set to 8. And the insert request has been rejected. That means our scan definition has still its original value. The attempt to re-import the modified version of that specific configuration element failed. And with version 7, called Symphony, we were now required to either manually delete the already existing item or to execute a batch utility provided by the beta support. So both approaches are very laborious, they are unwieldy, and especially they are error prone. You can imagine if you execute a utility deleting records from the target database, there is a large chance that you delete wrong records unintentionally. So with version 8, we enhanced the upload utility. And it's now possible to specify a certain control statement. The control statement is process equals auto update, which instructs this utility that in case a unique key violation is encountered, the mode will be automatically switched from insertion to update. Just a moment. I will a little bit enlarge the screen. Okay. So what is the result in this case? Let's have a look at the messages. So again, if you remember, the duplicate key condition is reported. And again, an internal command error is reported. But now there's a change. Because of the specification of auto update, process auto update, the utility switched from insert to update mode, as reflected in this message. And the result is that the command in this case could be successfully processed. So without the need to either manually or by a specified batch job to delete the already existing target record, we are now able to override the existing record. And if we update our message on our scan definition screen, we see that now, after the successful execution of that enhanced update utility, the already existing scan definition has now the modified, that's a mistake. Oh, pardon, I think we have to re-execute it. So let me start again and demonstrate how easy is it to re-execute a job that was the demo job before the session. Now it runs again, and hopefully now we have the modified. Sorry for the mistake. The demo job had been executed before the session, and then I reinstated the original environment. So now we see the change from the original title to the modified title. Let's recap. At this point, we have seen that the enhancement of the upload utility involves specification of a new control statement, process equals auto update, that enables us to insert, or more strictly spoken, to update modified records into databases with the same already existing unique key. And that greatly facilitates the daily work of an administrator in terms of deploying configuration items from the test or configuration system into the production systems. If you remember, the second topic was issuing a system message as a new event action type. So we are trying to have the system inform us about the internal switch to auto update. For that purpose, I created a so-called chain of scan definitions dealing with the BQL return code 142, indicating a duplicate key error. This chain of scan definitions does the following. First, in the case of a duplicate key condition, the name of the duplicate key is extracted and stored in a user field. You can see this here. I included the user field into a specific layout and called the column duplicate key. And you can see those jobs having encountered a duplicate key condition, either resulting in an error or a finally success, reflect the name of that duplicate key involved in the error condition. As with any field in our layouts, we are able to filter on this field. For example, if I enter a name pattern here in the search layout, I will only see the jobs having encountered a duplicate key condition. So the purpose or the aim is to get informed about an internal switch. So the next thing is to create an event. And as you can see here, the last member in the chain creates an event with a specific event ID. It's arbitrarily chosen, and the event ID is 2414. And the event is created only if auto update had been specified, but not in the case of an error where the insertion attempt is rejected. So we can distinguish in both cases, as you can see here, error or not error, we have extended selection criteria. In one case, indicating the automatic switch. In the error case, indicating a program return code which resulted in an error. So in both cases, we create extended selection criteria. But I constructed the last member in the scan chain to create an event only in the case of automatic switch based on the keyword switched in the job log. So at that point, for an administrator or any other user interested in that event, it's a good idea to start the inspection not with the usual jobs, it as version option 1, but to use the event tables. The event, remember 2414, that is created by means of the scan definition, is stored in the event table, and serves as a good approach to find any irregularities you are interested in. So let's see if we find any events with that specific ID. So, as you can see, any execution of the job with process equals auto update specified resulted in the creation of an event. And we directly get an overview of all the events related to an automatic switch. It serves just an example to demonstrate how the change of the point of view, it has the change from selecting jobs to instead selecting events representing irregularities in some form, could ease the collecting of information and the getting of an overview. From this panel, we have two options, two line commands. I for information, displays data associated with the event itself. Here you see the event text. It comes from the scan definition, raising the event. And by specifying S for select, we directly jump to the job creating the event. So again, it's a good idea if you're interested in irregularities to start with the event table, and in case you encounter any events you're interested in, to directly jump to the job causing the event. And the creation of the event was based on this line. It extracted switch to update and then created the event. But let's hold on for a moment and recap. We are now at the point where in one of the two versions of the program, namely the auto update version with automatical switch, we created an event, and the event data had been stored in the BQL event table. But still, we are required to look up ourselves now in the event table. And the idea was to create a system message. So we made use of the new function. We defined an event action based on that specific event. So you can see the last one based on 2414. I select this event action, and up to the Symfony version, there were two options, email or job. Now, with Lighthouse, there is a third option to create a system message. And in that case, I chose this option, message, based on the event ID 2414. And the idea was to enable the customer to specify an arbitrarily chosen message ID that best suits his needs. The only restriction is it must exactly be 10 bytes long. And again, you can specify a message text at your choice. In this case, we combined a constant prefix with a variable. With a % prefix, you indicate a log z variable. And in this case, the event text from the event itself is appended to the constant prefix. So this message is issued to the system log and to the log of the started task. So we inspect the started task. And as you can see, at 10.10, a system message had been issued with exactly this text: the constant prefix, launch day demo, and the text from the event. So, and our idea was to enable the customer to bridge the gap, as I initially told you, between the log Z automation and the system-wide automation. All system-wide automation tools, for instance, IBM System Automation, are able to capture system messages and to react upon them appropriately with a wide range of options. For instance, you could send a push message onto a mobile phone, or you could color a dashboard or something like that, or even start or issue a system command. So we give you the full functionality of your system-wide automation tool by issuing a message with an ID of your choice. Your automation tool can then capture and react upon. And as opposed to other system events, this system message is caused by text. It's caused by text of a job log. And that greatly enhances the ability to react on irregularities. For instance, you could find transaction rejected or something like that in your log and create a system message and inform an employee and to react upon it appropriately. Okay. So far for the second point. The third one would be the job correlator. The job correlator is a system token which was introduced by IBM some versions ago, and it's comprised of two parts. The first part, the so-called system part, is completely constructed by the system itself, and it serves as a unique identifier, even spanning multiple JES-plexes. Previously, the so-called and well-known JES ID had been unique only within the scope of one JES-plex. And as the need arose to have a unique identifier for the complete environment spanning multiple JES-plexes, this unique identifier called job correlator was introduced. Both parts of the token are 30 bytes too long. The second one is the so-called user part. And the customer can populate this field by means of JCL. So if we look into the JCL of our sample jobs, the event table. You see in the job statement a line specifying the user part of the job correlator. U for user. And you can choose an arbitrary text up to 32 bytes. And now logz is able to extract this information to store it in two separate fields. The system part is stored in the job base record, and the user part is stored in the job base record extended. The purpose of separating the two parts of the job correlator is that usually a customer would use only the user part as a filter criteria. So, as you can see, first, we included the job correlator, the user part, into this specific result layout. So I remove that filter to see more jobs. And now we will use it as a filter, for instance, to focus on the event log jobs. The search layout, all character fields support wildcards. So I would specify L as a starting letter, asterisk for a wildcard, and then as the intended suffix log. And as you can see, I only get the jobs specifying a job correlator user part ending with log. Another one ending with OGR. So this retrieval, storage, and separation of the job correlator and the separate storage of the two parts, of the system part and the user part, gives you as a customer the opportunity to specify criteria just serving as a label for your jobs, as a logical attribute, and to filter the jobs corresponding to those labels you provided, you assigned to your jobs. So the next part is the event log. First of all, event in this term has nothing to do with the log Z events we had been talking about. It's completely different. The JES event log is a new source of information, basically or mainly comprised of SMF30 records, which were created at the end of each individual step and finally at the end of the whole job. And the event log, the SMF30 records, contain a lot of statistical information and other attributes which are now retrieved, collected into a couple of fields and stored into new tables, one for the entire job and one for the individual job step. So, again, we have an overview of some jobs I prepared as a demo. And if we call the new line command F, it's the field info, we get now the information of all fields in the BQL, in the logz BQL database related to the selected job. So what had been a row in a tabular panel is now, let's call it a column vector, a scrollable column vector displaying all the fields in all tables related to this job. You can see the job base record fields, and as you scroll down, you see the job base record extended fields, and you see the user fields. And now the new table, the job event log record table. As far as possible, we adopted the same names as IBM uses in its SMF record descriptions. And that, in the case where the name by IBM is restricted to 8-byte length, we have a one-to-one correspondence. So, due to the quantity of the fields, our idea is, if you're interested in a detailed inspection of that fields, you would then have a look into the IBM documentation. You see, that's a part of record type 30 description, and the information is separated into different sections. And for instance, there is a processor accounting section, and it contains very interesting information, especially on ZIP or ZIIP. You can see how many time the processor spent on ZIIP and compare this to your expectations. And one very interesting and important field is this one: accumulation of CPU time spent running ZIIP eligible work on a standard CP. Well, why is that so important? Because, for instance, if you run a DB2 workload, you would expect main part of that workload to run on a ZIIP processor. But if the system encounters a bottleneck in the availability of ZIIP processors, a so-called ZIIP needs help mechanism will have the CPU, the general CPU or standard CPU processors take over, and your work originally eligible for ZIIP in fact would run or will have run on standard processors. And certainly that's not what you intended. And if that field is not zero, you will be informed that there had been a bottleneck in CIIP processor availability. The corresponding database fields are those. And you see the long names, we chose numerical suffixes, but tried in the description to reflect IBM's naming conventions. So you should be easily able to correspond those fields in the database with the description IBM provides for the SMF30 records. We also included sections recently added to the SMF30 record types. For instance, the CEDC usage section related to hardware compression. Those fields here. Then fields to the hardware crypto processor. You can see how many instructions use the hardware crypto processor, and because it's a buzzword, artificial intelligence, you also see a counter for the NNPI instructions. NNPI is an acronym which stands for Neural Network Processing Instructions. And that are the Z instructions directly developed for supporting the executing of AI models that had been trained on other systems, but can certainly and well run on the Z system. And that is the hardware support for those AI models running on Z. And you have an information on to what extent this hardware support has been used by the specific job. So that's quite a lot of fields. And up to now, we already saw the content of those event log fields by displaying the line command, the column vector, that is for the whole job. And you also have the opportunity to select the fields based on the individual step. And now you see different table names. It's not the job event record, it's the job step event record. The values now reflect the counter data for the individual step, whereas the job data reflect the accumulation, the aggregation over all steps the job is comprised of. In order to evaluate and to get an overview for the event log data for several or even for many jobs, you could use the report generator tool. And I created an example. So that's the source of the report. And the result is or more strictly spoken, the result is divided in three parts: 2 reports and a punchline. Let's start with the reports. They are grouped into sections, just as the description of the SMF30 record fields by IBM is grouped into sections. So for this example, I chose a section reflecting the CPU and I/O statistics. So reports are restricted or limited to a length or width of 133 bytes. The field total XCP, that is the sort criterion. It's sorted descending according to that field. So I chose to display all jobs from several subsystems, as you can see here or here, sorted in descending order based on the total XCP, as execute channel program instructions, the total I/O instructions in this job. And that field is the CPU time in hundredths of seconds. If you're interested in samples for such reports or in guidance to create those reports yourself, please reach out directly to us, or especially to me. We will provide you with a rich variety of examples to evaluate the BQL database in general, and especially the new event log tables. The second report, storage, is related to the storage section. For instance, these two fields relate to high virtual, which means above the bar. And there's a lot of fields related to the usage of regions and virtual storage. And to have all this information in one wide line, we used the punch facility. So, and semicolon as a separator value. So this format would suit the need to export it and import it into Excel, for instance. So very wide line, all information combined in one line for each job. So the idea was to introduce on the JCL level variables specifying a threshold serving as filter criteria for the jobs to be reported on. Can very easily adopt it to your needs. And again, if you're interested in examples or guidance and advice, please reach out to us. So, short recap at this point. Up to now, we've seen deployment of already existing items by means of auto update, the recognition of such internal events, and the creation of a belonging related system message, both to the log of the starter task and to the system-wide job log. We have had the job correlator as a filter criterion and as a displayable tabular field, and the new source of information, the JES event log. Again, please do not confuse with the term events in terms of log Z. providing a lot of statistical information for a given job. And in context of the JES event log, we already saw the new line command F for display all fields on the job and on the step level. Now let's proceed to the handling of outlim. Let's recap the status of version 7. Outlim processing is specified via the class definitions. As you can see, the class definitions can specify an outlim threshold that instructs the reader to reject any sysout dataset exceeding this number of lines. Rejecting means, in this context, the reader will not store the list in the log-z spool, but instead requeue the list to JES by specifying a new target class. For example, for our regular sysout class Y, we have specified a threshold value of 1000 lines, and we tell the reader, in the case that this threshold is exceeded, the corresponding list to requeue to the new output class X, and to assign the hold attribute to the list. So let's see the effect. So I'm interested in only jobs with the outlim error, so I can filter job error text, outlim. Okay. You see only outlim error jobs are selected. I'm going to re-execute one of them. So you can see, and the time, that's the current one, just created. And if we look at the sprint output, we see only 3 lines of data. If we select the sprint, we do not see the original, the actual data, but instead we are informed that the list exceeded an outlim threshold, namely 1000 lines. Our list had 1344 lines, and therefore its retrieval was rejected and it had been requeued to class X. Again here. So where's the data at that moment? We are here in SDSF and we specify the held class for this out class X. We specify the job name or the pattern, and we see the data we are missing in the log Z is here on the held queue in class X. That is our data. So at that point, with version 7, we could decide we are fine with the data being in JES or staying in JES and not being read in by log Z, or if we wished to have log Z eventually read in this data, but under the control of a specified job group, of a parameter set specifically tailored for the needs of very large lists, we had to start a separate started task with a dedicated reader for large lists, because it was not possible to read a list that had been once rejected due to outline. It was not possible to reread such a list in the same address space. And address space in that term is our main task of log-z. So it was very laborious and unwieldy in such a case to maintain, construct a separate started task, to start it by automation and so on. And the enhancement of version 8, it as Lighthouse, is to allow for a specific reader in the same started task. So, and in this case, you see the reader for the same started task, class X. We have a look at the readers, and we see now we can define a reader for that specific class X, the outlim class, and the name, which is identical to the subsystem of our main task, indicates that this reader belongs and can be started and will be running in the same main task of our log-z, which formerly, again, was not possible. So, but the reader, at this point, you can see dormant means had not been started automatically when the started task was initiated. So the reader is still sleeping. If we are interested in reading in the outlim sysout datasets currently maintained by Jess on the X queue in a status of hold, we would have to start this reader. So let's have a look at the reader definition. As you can see, the reader will read in class X, but not the hold queue. It will only read in released output. The writer queue.
The broadcast is now starting. All attendees are in listen-only mode.
What we can see is the HX queue, it's still there. The reader has been started, but the output is still in Jess. Why? Its output disposition is hold. And again, we saw the reader will not read hold or held data, only released data. So if we now decide, after inspecting this kind of large list, that we would like this list to be read in by the reader and finally be stored and saved into the log-z spool, we will have to release this large list by means of the O line command. That's a Jess SDSF line command. And now you can see this list has vanished, has disappeared from the held X output, and hopefully it has been read in by this specific reader. So if we reselect the job, we now see the sysprint output twice. 1.6 is the original 3-line output informing us about the fact of an outlim violation of a list exceeding the outlim threshold. And in the second attempt, after first starting the reader and second releasing the held output, we got the original 1,344 lines. Okay, but this, let's say, laborious or apparently somewhat unwieldy way of reading in large or very large lists was only for demonstration purposes. In reality, of course, you could do two things. First, you could start this specific outlim reader, the reader dedicated to processing outlim lists, automatically when the started task is initiated by simply specifying active as for the other readers. So you were not required in this case to explicitly start the reader in case an outlim accession is encountered. And second, of course, you could either have this reader also read in held output by specifying yes for this field. Hold Q yes would mean held output is also retrieved by this reader, or the other way would be the class definition to specify no hold for class X, just as it suits your needs. So specifying X and hold and the reader having not automatically reading in held output gives you the chance to inspect the lists before making the decision of it should be read in and saved by log Z or not. But in our case, our advice, best practice would be to automate this processing, again, by starting the dedicated reader automatically together with the starter task, and either specifying no hold in the class definition or specifying in the reader definition that it will also read in held output. One of those two choices who would result in the reader or the log Z main starter task automatically, without any manual interception, automatically reading in very large lists, but at the same time, it would give you the opportunity, and that's the purpose for all this processing in our sense, to assign a job group specifically tailored for processing of very large lists. You see, in our case, I assigned a job group by specifying class processing active as yes, and by assigning a specific job group outline. And the idea and the purpose behind this so we go into the definition of job groups. You can see the outline group specifies 0 days retention period. So one basic idea is to assign very short retention periods, even 0 days, to very large lists. And the effect would be that those very large lists, while being read into log Z and being stored and possibly archived, you wouldn't waste space in your log Z spool by having the next run of the daily job deleting the lists from the online spool, and the lists would then only reside in the archive. That would one idea to handle very large lists, not to waste your spool storage. And the last part, just for demonstration purposes, have a look at the job again. You see an output statement. Output statement specifying lots of output-specific print-related parameters. We are now able to store in a new table the output generation record, and the new line command O for display output palms reflects all the parameters you specified, and these parameters can be used for later printing if it's required. So if we print this list to class O and specify use saved output parameters, yes, we instruct the print program to use exactly that parameters that were initially specified in the JCL and had been stored in the output generation record. Now for the printing request, we execute it. One list printed under the name of the started task, and we see the result, the output queue for O, specifying again the started task. Wrong key pressed. So, and you can see the print output, and if we invoke the column vector SDSF provides, vom 20.09. You see here exactly the demo data, building, address, user data, just as we had in the JCL. Compare these output palms were initially specified, had been stored, and are now conveyed via the print request again to the JES pool. So at that point, 11 o'clock, that's what I like to demonstrate you, to present you. And again, the purpose of this session is to give you an idea of how the new functions work, how they interact, and of course, what purposes they could be useful for. And if you are interested in to get advice, to get guidance in making use of these features and even of well-established features of former versions, please reach out directly to us. Thank you for your attention.